In the previous part, we used the CELUS design platform for the AI-based hardware design. Then, I transformed the schematic into the regular PCB layout. Today, I will show you how I manufactured this agriculture smart I/O board. We will power it up for the first time. The next step will be the software part. We will build a foundation for a full featured application with blues.com Notecard and Notehub. Let's start with the board manufacturing. Each PCB assembly begins with the printing of solder paste. I am using the Stellar stencil from the Eisler company. The following job involves placing each component onto the solder paste layer. I usually start with small components, but it's not a strict rule. I am using the interactive BOM plugin for KiCad. I spent the last 30 minutes preparing the component bags and reels. When all packages are in place, I can solder them using a hot plate reflow heater. I set the temperature to 260 degrees centigrade. It takes a while until the top copper layer reaches the solder paste melting temperature. Initially, some components shift slightly out of position. When all component pads are at the same temperature, each device centers itself. I'll remove the board from the hot plate after a while. I've got to be careful because any sudden movement can damage the assembly. This is the photo of the soldered board. Now I manually solder the THT components. The Blues I/O website provides us with a detailed quick start manual. To get familiar with the system, I will start with the original Node Carrier XP and the Notecard Wi-Fi. The screw on the upper edge of the Notecard is quite important. Otherwise, the Notecard can jump off the Node Carrier. It's time to connect the Node Carrier with the computer. The Notecard Quick Start manual begins with connecting a Notecard. Awesome! The Notecard is paired and connected. So, the browser terminal app works. And I can mount the Notecard onto the agricultural switch I/O board. Now, the input power supply cables. Oh, something bad is happening. The Notecard blinks, but the Notecard is not found. There must be something bad with the board. See, here is the devil. When refactoring the schematic blocks, I accidentally swapped the USB lines. Such a beginner's mistake. What can I do? I have to repair it by cutting the tracks. I managed to switch them using jumper wires. Hooray! Even my board works with the Notecard. That's a happy moment. Okay, the board is paired. The next step is to set up Notehub. First, I have to sign up there. Let's create a new project. The project name is Agriculture Smart Switch. The product UID must be globally unique. I believe info.𝗿𝗶𝗿𝗂𝗏 is unique enough. OK, create project. Add a new device. The documentation states that I need to copy the product UID and update the example JSON string. No problem, here is my prepared JSON entry. See, the board restarts itself. After the reconnection, the Notecard terminal output is quite active. It seems it works well. Let's sync with the hub. Yes, the terminal output confirms the successful execution of the command. Now, I should be able to see my device on the Notehub device page. Wow, it's there! It works! My board works! Yes, I'm doing great. Now, I want to send some data to the cloud. Let's follow the tutorial. Oh, is it that simple? I am surprised by the simplicity of the JSON entries. The first node is in the cloud. The return is 1. It means there is one node waiting to be sent when syncing with the Notehub. Now it's synced. Let's check the events. Voila! Look! My first node is in the Notehub cloud. Okay, now from Arduino. The tutorial asks me to install a Node-Arduino library. Let's do that. The Arduino library manager will do the job. I'm looking for the Node-Arduino. The official library name is different. This one should be the library I am looking for, Blues Wireless Notecard. I copied some example code snippets. Don't worry, at the end of the video I will show you the entire Arduino code. I am compiling and uploading the new code with the initial hub.set JSON entry. It takes a while until the uploading job is finished. Okay, the Notecard is alive. What is in the tutorial? The example code sends some pseudo sensor data using the Notecard pseudo sensor library. Let's try it. Here is the example code, and here is my code. My code now contains dummy node sending with pseudo temperature and humidity values. After the firmware upload, the event log is filled with positive log messages. Every 15 seconds, a new node is being sent. Now, I would like to receive messages from the internet. I added some code for reading the remote file name sensors.qi. Sending commands is protected with a so-called bearer access token. The sending side must ask for such a token and include it in the request message. The tutorial section titled Remote Command and Control describes the entire process. Here is my request to send a command on2 to switch the second binary output. Now you can see the message from the Arduino indicating that the incoming command on2 was processed. Now let's switch it off. I have to change the command phrase to off2. Now the off2 message was processed and the output is off. Awesome! Let's check the event log. Yes, the commands are there. The command on2 and the following off2. It means that now I can send the sensor data or, in fact, any data to the cloud. Additionally, I can receive a command from a remote application. That's all I need to build a genuine application. Not a demo. I promised the code review. Here it is. The initial section contains the unique product UID string. Below are my output port definitions. The common Arduino port initialization is here. The first Notecard command is here. The code sends the configuration JSON with the continuous mode request. And after 2.5 seconds, the hub.sync request is issued. The main loop contains a second-based timer. Each second, the status LED blinks. Every 60 seconds, the pseudo sensor data are sent. Every 10 seconds, the hub.sync command is sent. The purpose is to shorten the delay in receiving commands. Every 5 seconds, the new entry in the sensors.qi remote file is checked. If a new entry is detected, the message is decoded and processed here. As the last task, the processed command is deleted from the remote file. And that's all. The simplicity of the entire solution is incredible. As you can see, the only issue was my hardware design mistake when I swapped the USB lines. The rest was a piece of cake. The entire Notehub setup is straightforward and easy to implement in the code. Even I, the non-programmer, can build an application that sends data to the cloud and receive commands from the remote controller. The combination of CELUS design platform, KiCad and blues.com works seamlessly. Feel free to copy my code and build something amazing. I encourage you to use the AI for wipe coding and your MVP is ready in days. If you want to start with my code, please send me a DM and I will reply with the code archive. Thank you for watching. See you in the next one.